Hi there, Form 1s. In the following video, I'm going to be working through question number 6 and question number 7 from your June 2015 exam. Question number 6a. From x squared minus 6x plus 4, subtract the sum of x squared minus 5x and minus 2 minus x squared. Now, the first thing we need to remember is that the order in which we write this in is hugely important. To help us understand the ideas of from, subtract, and sum, I want to give you the following scenario. If I had to say to you, from the hall, go to the pool, I think you'll agree with me, I'm starting at the hall and I'm going to the pool. If I had to say to you, go to the pool from the hall, you'll agree I'm still at the hall as my starting point and I'm still moving towards the pool. Hence, for this question, I'm going to say from x squared minus 6x plus 4, I'm going to write down x squared minus 6x plus 4. From that, I need to subtract the sum of x squared minus 5x minus 2 minus x squared. Now, the reason I've included brackets on this part is because this entire sum needs to be subtracted. If you omit these brackets, then only the x squared will be subtracted. So remember that. When doing the subtraction, remember to add brackets. Let's do some collecting. I've now got x squared minus 6x plus 4 minus, open brackets, x squared and negative x squared, collect like terms, that gets me 0, minus 5x and minus x, that gets me negative 6x, minus 2. I now need to use the distributive law. I get x squared minus 6x plus 4 plus 6x plus 2. Pay attention to how I've distributed negative 1 into this bracket. I now can collect like terms again, and I get x squared plus 6. In B, we have for each of the flow diagrams, write down the missing components. An example is being given, and I'm going to encourage you to use the example to make sure you understand fully of what the question's asking. In the example, we have 4 into 2x plus 1 gets 9. Now, when I say into, I mean we need to take this value of 4 and place it in here for x. So if I put 4 into 2 times x, if I replace the x with a 4, I think you'll agree that gets me 8. 4 times 2, 8, plus 1, that gets me 9. Let's try it for the first question. So here we've got 3, must be placed into 3x minus 1. So hence, I'm going to do this as 3 instead of x. So 3 times 3 is 9, and I subtract 1 from there. I think you'll agree that gets me 8. In the next one, I have negative 2. Hence, negative 2 squared gets me 4. 4 times 2, that's 8. And 8 plus 1, well, that's 9. And in the last one, in 3, this one's a bit tricky, because here I haven't given you the input. I've given you the output. Can we work backwards? Well, maybe we can. Let's consider the example again. 4 is the input. When it's put into here, I get 9. How would we work from 9 back to 4? Well, we need to work backwards. The first thing I did was multiply by 2 and then add 1. So now I'm going to subtract 1 and divide by 2. Let's try that. 9 minus 1. Hope you understand why I'm saying minus 1. Hence, divided by 2. So 9 minus 1, 8. Divided by 2, 4. Stunning. Let's try it here. So we have a negative 2 as the output. I'm first going to subtract 5. I think you'll agree with me. That gets me negative 7. And now I'm going to divide by negative 1, which gets me an answer of 7. In question 7a, solve for x. Number 1, 3x plus 3 is equal to 18. 3x plus 3 is equal to 18. I'm going to transpose the 3 and get 3x is equal to 18 minus 3, which gets me 3x is equal to 15 by collecting like terms. So what I've done there is get my variables on one side and my numbers on the other. I now think about what's the coefficient of x, and I think you'll agree that's 3. Hence, I'm going to divide by that coefficient. So if I divide by 3 on both sides, I get an answer of x is equal to 5.